That's MB. Now what I'm going to do is to write the expression of y of x and y prime of x in the following way. But first of all, recognizing that y a, which is when x equals 0, y a is nothing but just y of x when x equals 0, right? And yb is nothing but y of x when x equals L. And so we're going to call this to be delta A, and this to be delta B, and the same thing for theta and theta B. So we're going to say that theta A is just y prime of 0, and theta B is just y prime of L, right? Just replace all these coefficients because what we want to try to do is to get the expression of delta A, delta B, and theta and theta B, which should be familiar to you. Now, with this, we're going to write this expression, which is we're going to say that theta A and theta B can be written as this. It's going to call by this coefficient in this matrix, which is F11, F12, F21, F22 times MA and MB. This is terrible writing. Okay, now let's check them one by one. When I wrote theta A, which is the slope, that means we are looking at the slope expression, which is y prime, right? In this case, that means what? That means when you plug in x to be 0 in this expression, in y prime of x, you're going to get expression of theta A. And whatever the coefficient associated with MA here, goes to F11. Is that clear? Now, whatever the coefficient associated with MB goes to F12. This is important. When you plug in x equals 0. When you plug in x with capital L, you get expression of theta B. And in that case, whatever the coefficient associated with MA will become F21. And in that case, whatever the coefficient associated with MB will become coefficient F22. So without the burden of plugging all these values and expanding everything, I just explained to you that how we're going to get these coefficients F11, F12, and F21, F22, because you can easily get them. You already have the expression of y prime of x, right? So you know that how to plug this in and to get those coefficients. Now, the expressions of F11, F12, and I can actually just give you this result here. So that means F11 actually equals to F22, and that equals to L over EI times sine KL minus KL times cosine KL divided by KL, the whole thing square, and times sine KL. This is F11, it also equals to F22. For F12, it also equals to F21. And expression is L over EI times sine KL minus KL divided by K and L square and sine KL. So these are what we call flexibility coefficients. Sometimes people call them flexibility functions. Now, remember this expression, how we relate angles, theta A and theta B to the MA and MB. The next step, step 4. If we have that equation, how do I gonna get the expression of MA and MB? Suppose I want to find out MA and MB. The way we're gonna do it is we're gonna calculate the inverse. So all you need to do is to find out the inverse of this flexibility, and you actually can call the whole thing flexibility matrix. So we should come back and to properly define this. We will say that this whole thing, F11, F12, F21, and F22. This is flexibility matrix. And then we come back here. To find out the values of MA and MB, we will just have to calculate the inverse of this, which is the inverse times theta A and theta B. We just have to do this. And the inverse of this, we're going to call them a new matrix. We're going to call them C11, C12, C22, C21, C22 times theta A and theta B, like this. And then I will just give you the expression of C11, C12, and C21, C22. Of course, because the flexibility matrix is symmetric, and its inverse should also be symmetric. That means C11 equals C22. That equals to EI. You can see the flip of the coefficients here, times this whole thing. It's a little bit lengthy, but it's not that complicated. It's KL times sine KL minus KL, K and L squared times cosine KL divided by 2 minus 2 cosine KL minus KL times sine KL. Like this. And we said this is related to another coefficient. We call it SII. And we will get to that momentarily. C12 equals to C21 equals to EI over L times another thing. Downstairs all the same. 2 minus 2 cosine KL minus KL times sine KL. Upstairs, it is K and L squared minus KL times sine KL. And we said this is related to another coefficient with a factor EI over L. And we call this Sij.